Hey, it is day 11, and I'm going to be doing some coding. So let's uh, let's make a file. I forgot to do that ahead of time, and let's go see what the problem is. You enter a large cavern full of rare bioluminescent Dumbo octopuses. Seem not to like terms of lights, you turn them off for now. There are 100 octopuses arranged neatly in a 10 by 10 grid. Each octopus leads into energy over time. Flashes brightly for a moment when its energy is full. Though your lights are off, maybe you could navigate through the cave without disturbing the octopus if you can predict when the flashlight will happen. Each octopus has an energy level. Each substitute can remotely measure the energy level of your puzzle input. For example, let's do this. The energy level of each octopus is valued between 0 and 9. Here the top left has so on. All energy levels flash in steps. First, the energy level of each octopus increases by run. Then, any octopus with energy level greater than 9 flashes. This increases the energy level of all adjacent octopuses by 1, including octopuses that are diagonally adjacent. If this causes an octopus to have an energy level greater than 9, it also flashes. This process continues as long as new octopuses keep having their energy level increase beyond 9. Finally, any octopus that flashed during this step has its energy level set to 0, as it used all its energy to flash. Adjacent flashes can cause an octopus to flash on a step, even if it begins that step with very little energy. Consider the middle octopus with 1 energy in this situation. For any steps this, after step 1, after step 2. An octopus is highlighting when it flashes during the following step. Okay. Etc. After step 10, there will be a total of 2 or 4 flashes. Fast forwarding your same configuration every 10 steps. This. After 100 steps, there have been a total of 16. Even starting to simulate 100 steps. How many total flashes are there after 100 steps? Okay. So let's just do it the naive way. Energy level of any octopus increases by 1. Any octopus with an energy level greater than 9 flashes. This increases the energy level of all adjacent octopuses by 1, including octopuses that are diagonally adjacent. Okay, we'll just start doing this. And actually, you know what? I'll just do it this way. This is easier. Let's say xy equals tuple int int. That's easy enough. And class grid. That is good. Let me. Grid. I went grid. Okay. So I need iterable. And let's say self.grid equals, and we want to int x for x and row for row and grid. That's right. Self.nr equals len grid. Self.nc equals len grid 0. That's good. Right, self.grid. Okay, so that's good. And so now what I want to do is I want to so each time I step, I need to talk how many flashes. So let's do def step self int returns the number of flashes. Okay. And so now, let's say flashed equals set. And so let us read these instructions again, because first energy level, each octopus increases by 1. Then any octopus with an energy level greater than 9 flashes. Okay, this increases the energy level of all adjacent octopuses by 1, including octopuses that are diagonally adjacent. This causes an adjacent octopus to have an energy level greater than 9. It also flashes. This process continues as long as new octopuses keep having their energy level increase beyond 9. Octopus can only flash at most once per step. Finally, any octopus that flashed during this step has its energy level set to 0 as it used all of its energy to flash. Okay, so actually, okay, so start by increasing every energy by 1. Okay, that's right. Okay, that's good. Okay, and actually, let me do def neighbors. Including diagonally adjacent. So, if zero less than or equal to I less than or equal to self dot nr and or less than self dot nr. So I don't like the way they wrote it. And 0 is less than or equal to j and ij not equal to, okay, that I like that way much better. Yes, that's much better. Okay. So now I have neighbors. And so what I want to do is as follows. Let's just say well, continue equals false. And so first what I want to do is say frontier equals this. I don't know why this says code is unreachable. For I in range this, for j in range and c, if self.grid is bigger than 9, flash. So I want to do two things. One, I'm going to set it to flash and then add all non-flashed neighbors to the front. Go back and read this. Increases the energy level of all adjacent octopuses by 1, including octopuses that are diagonally adjacent. I don't know what this junk is. Okay. Okay. If self.grid is, was it bigger than 9 or bigger, integer or greater than 9? Bigger than 9 and ij not in flashed. Okay. Let me do it this way. While true, this. If not need to, if there's nothing that needs to flash, then break out of the while loop. Okay, good. And now need to flash. So flash dot append ij, and then I need to not append because it's a set, add ij, and now I need to increment all of the neighbors for jj in self.neighbors ij, self.grid jj plus equals 1. So I think that's right. And and so then I need to do two things. Set all flashed cells to 0. Let's see if Copilot can figure that out from this. For ij and flashed, okay, good. And return len flashed, okay. So let's see if this works. Grid equals grid of raw.split lines, okay. And my guess is this won't work. After step 10, there have been a total of 204 flashes. Search sum of grid.step for blank in range 10 equals 204. So let us try this and see if it works. It probably won't work, but hey, it did work. That's good. And after 100 steps, there have been a total of 1656 flashes. When did I say 1656? 1656. Okay, so if this is right too, then probably we got the logic right, and we can keep going. Okay, that was a little bit slow, which I don't like, because that suggests that, oh, this one's not too big, so that's fine. Day 11.text. That's not what I want. What I want is raw equals open data day 11.text.read grid equals grid of raw.split lines print sum of I think that's right. They wanted after 100 steps. Is that correct? How many total flashes after 100 steps? All right, let's try it. 1642. That's the right answer. All right. Seems like the individual flashes aren't bright enough to navigate. However, you might have a better option. The flashes seem to be synchronizing. Example above, the first time all octopuses flash simultaneously is step 195. You can calculate the exact moments when the octopuses will all flash simultaneously. You should be able to navigate through the cavern. What is the first step during which all octopuses flash? Let's see if we do this naively, if it'll work, or if it will just run forever, and we'll have to reason outside. So we will import iter tools, and what we will say is for step in iter tools.count 1, if self.step equals self.mr times self.mc, return step. Okay. Raise value error cannot get here. It shouldn't be value error, it should be a runtime error. But I only did that because the int was underlying, so it's saying that it doesn't understand this is infinite. So okay, and so let's see. The example above is step 195. Okay, so let us assert that grid steps to all flash equals 195. Good. All right, well, let's see if this works or not, or if it will run too long. 220. All right. That's not the right answer. Curiously, it's the right answer for someone else. You must be logged into the wrong. Oh, I know what the problem is. I need to reset the thing, right? Because we're destroying it. So we need to create a new grid, and so basically there's an extra 100 steps that we're missing. So let us do that again. It's 320. Okay. Oh, come on. Like I like on one hand I get that they don't want me to keep guessing, but 21. 1, 2, 3, 4, 5, 6, 7. That is the right answer. Okay. So that was a silly mistake, but basically because I'm destroying the grid at each point, I'm already 100 steps in, and so when I did this, I was off by 100. Anyway, is there anything worth talking about here? Obviously, you know, I tried to let copilot write this neighbors function. I hate writing these neighbors functions, but it didn't write the way I liked, so I rewrote it anyway. But there's too many ways to get off by one errors that I don't like. And then the tricky part here was figuring out how to do the bookkeeping and understand the instructions, right? So, you know, increment by 1, keep track of who's flashed, and then just do this infinite loop where I say, is there anyone who needs to flash, meaning that they have too high a number and they have not flashed yet, and then just break out whenever that stops being the case. Otherwise, go through the ones that I need to flash, add them to this set of things that have flashed so that I won't count them again, and increment all the neighbors. it may be the case that because of this, some things get incremented extra times to like 13 or 14 or whatever. That's okay. It doesn't really matter because all we're doing here is checking that they're high enough. And then, set the flash cells to 0 and return the length of the flash. So it was a little bit fiddly with the instructions, but otherwise, I think it was pretty